let's look at a special case when we're graphing for solving a system of equations. So the question here would say, solve a system of equations. So we have the two equations in this case, and we want to find out what point satisfies both of these. So notice that there might be something funny here because we have this word special. So this is going to be a special case of this. Let's see what that means. Alright, well, we're going to solve this one through graphing. We have three ways that we can solve a system, and we're going to go through all three of those ways, but the first one is we know that we can graph these equations and we can solve for them. I'm going to put this over here. That's our objective, solving the system. And first thing is, let's graph this. Well, I'm going to use slope-intercept form to graph this. So slope-intercept form, my first step is to find the y-intercept. Well, for the blue one, my y-intercept is at -2, so it's right there. So I'm going to graph that, and we'll do it in blue, -1, 2. And what is my slope? Well, my slope is this 3 right here. So it's the same thing as 3/1. So I'm going to rise a +3, and I'm going to run a +1. Let's look at that. If I rose a +3, run 1, that is my line. So I get this line that goes through those 2 points. Okay. So now this equation on this side, it's not as nice and neat, it's not in slope-intercept form, and that's not a problem because we can do that. I'll put the scaffolding on this one. So in order to get the y by itself, we have to add 6x to both sides and subtract 6 from both sides. So I'm going to add 6x and subtract 6. I'll put in an addition sign there. That puts me down to this step. 2y is equal to 6x minus 6. Now I need to divide both sides by 2, and divide everything by this 2, so that gives me y is equal to 3x minus 3. Alright, all that, put this in slope-intercept form, which a lot of you are very quick at. If we look at this graph now, you'll notice something, but let's go ahead and graph it first. A lot of you might notice what's similar here right away. Well, the first thing is, let's go to my y-intercept. My y-intercept is -3, so -1, 2, 3. That's right here. Now my slope is 3 again, so I rise 1, 2, 3, and run 1. There's my second point. And I graph this, and you'll see that these two lines are, what's the word for it? They're parallel. They're parallel. So that means that they never crossed. So if they never intersect, my solution for solving the system of equations, well, remember my solutions where they cross. If they never cross, then it is no solution. Alright, so we have that. Let's do another one. Oops. Alright, so let's say instead of having a different y-intercept, let's make this the same y-intercept. So let's see what happens if I change that from a 6 to a 4. Now when I put this in slope-intercept form, I'm going to skip the scaffolding on this one. I get 2y is equal to 6x minus 4, divide everything by 2, and I get y is equal to 3x minus 2. So you can see that these are the same lines now. These are both the same equations, so they're the same lines. What's that mean when I graph it? Well, the same line graphs the same exact way. It's the same thing. So how many solutions do you have? Well, every point on this line represents a solution. So if it's the same line, that means that any number on one line will be on the other line. So that means that there's an infinite number of solutions. Infinite. Infinite number of solutions. Same line, infinite number of solutions. Okay. Okay, now if we look at the special cases with substitution or elimination method, let's look at what type of answer we get, and that will tell you if it's a special case. So if we take the same two equations right here that we did before, and let's say that we want to do elimination method. So we'll just show elimination method for this one. Okay, well, elimination method, I want to cancel these out. So remember, from elimination method, I have to figure out, well, what am I going to cancel out? Am I going to cancel out my y's or my x's? Oh, let's cancel out this y right here. So in order to cancel out the y, I'd have to multiply by 2. Multiply everything by 2. And then that becomes 2y is equal to 6x minus 4. And this equation right here, well, I'm not changing that. So when I bring this over here, now with elimination, I'm going to subtract these. So when I subtract these, 2y minus 2y is 0. Let me put the subtraction sign in here. And I'll put subtracting the whole thing. 6x minus 6x is equal to 0. And negative 4 minus a negative 4, well, that's negative 4 plus 4, it's equal to 0. So what I get is 0 is equal to 0. Whenever you get 0 is equal to 0, this is when you have the same line, and you'll get good at recognizing this, or you have infinite number of solutions. So if it's the same line, same exact thing, you'll get 0 is equal to 0, and it's an infinite number of solutions. Alright, let's look at this now. Alright, let's say that we had, instead of the same line, we're going to differ just a bit, so we'll put a 7 right here. Alright, now same step. If we do the elimination method, I have to multiply everything here by 2. So let's just do that right here. So multiply 2y by 2. This becomes a 6. Multiply this by 2 and I get a 4. Now I want to add these together, or subtract them. So if I subtract these full equations, then what I get is, on this side, well, those cancel out. Let me put the parentheses back around here so you know we're subtracting everything. Which is equal to 6x minus 6x is 0 again. Negative 4 plus a 7, because a negative and negative becomes a positive, equals a positive 3. So now we have 0 is equal to 3. So whenever you get this, if you get this, 0 is equal to something, or two numbers that definitely are not equal to, let's just say that you get something that is not true, two things that are not equal, well, then the answer is no solution. So let's sum this up real quick. So one solution, well, one solution graphically, it's when we get two lines that cross, and it has one solution right here. No solution? Well, no solution is when you have two lines that do not cross. They're parallel. An infinite number of solutions is when we have the same line, so it's the same exact line. And you'll get good at recognizing the graphs. For one solution, we would have something like y is equal to negative x, and y is equal to 1/2 x plus 1. This is just an example, but we can see that we have, let's write this in, we have different slopes. That's the requirement. So different slopes, we'll get one solution. For parallel lines, this is if we have the same slopes and different y-intercept. And I'll write an example of that one as well. Same slope and different y-intercept. That could be y is equal to 3x plus 2, and y is equal to 3x, but we want a different y-intercept, so we'll say minus 1. So there's an example of that. And infinite solutions, well, this one is, let's say we have y is equal to x plus 3. It has to be the same one, so we have to multiply everything by the same amount, so that we could say 1/2 y is equal to 1/2 x plus 3/2. So that's the same one. Okay, I hope this helps, and hope you can recognize the special cases of systems of equations and solve them easily.